Okay, hello everybody. Um, it's a beautiful day in Dublin under restrictions five level five today, and we are here to welcome you on our next guest lecture talk organized by UCD School of Sociology, and I'm very pleased to present our dear colleague Taha Yasseri, an associate professor of the School of Sociology here at UCD Dublin. Formerly, he was a senior research fellow in computational social science at the Oxford Internet Institute and many other things he's going to present by himself. So the stage is yours. Enjoy. Thank you.
Thank you very much, Leah. Thank you everyone for joining me today, and thank you for giving me this opportunity to talk a little bit about my research and my work. Well, I would have started by asking, how are you? Are you well, Dublin? But unfortunately, I can't hear you back, but so I hope you're all well. Also, I'm not sure if everyone is from Dublin or is based in Dublin at the moment. I hope some of you are actually from further distances, possibly other countries. And that's one of the good things about online presentations, apart from the fact that you wouldn't know what I'm wearing under my wrist. I often think about geography, and I am often asked about geography in different ways. First day at UCD, I went to pick up my new university card, and as I was telling my name, spelling my name, to the lady who was issuing my card, I could see how confused she is with my name and spelling, and sure enough, she asked, "Where are you from?" And you know, often this question is not about, oh, I'm interested in you. The question of where are you from often means you're weird, your name is weird, or the spelling of your name is weird. And it's a bit hard to hear that in Ireland with all the spellings of the names. But anyway, so I gave her an answer to the question of where I'm from. And I thought I can share the same answer with you just as a quick introduction. So this map shows the places that I lived in. I was born and raised in Tehran, in Iran. Uh, this is not how I looked like when I was born. A few years after, there are not many pictures from that moment, but I think here I'm 4. And well, I went to high school. I went to high school in Iran in 90s, and looking like this, going to high school in 90s is not great fun because everyone wanted to look like Leonardo DiCaprio back then. And my attempt to look like him miserably failed. So I gave up eventually and went for the Jesus look for a few years until I finished my bachelor and master's in physics and moved to Germany to continue my PhD in physics of complex systems. And because of the humidity in Germany, my hair started to look like this for a few years, which was not great fun. But I finished my PhD and then I moved to Budapest in Hungary to do a postdoc, still in the physics department. But the thing is that, well, Hungary is a little bit of a racist country, so I had to have a bit of disguise and often appear in public with things like this. And after 2 years, I went to Finland for a few months, but I don't have many pictures from then because, well, it was cold and dark. And it was also a short period of time just before I went to Oxford, where eventually I had to cut my hair and put on tuxedo and pretend that I'm interested in small talks. Well, I spent 8 years in Oxford at the Oxford Internet Institute just before coming to Ireland. Well, theoretically this July and practically this September. Well, I had to move the map because Ireland is so much in the corner. So this is how I arrived to Ireland in September, a little bit piratey because of the mask and everything, but I'm very happy to be here, to be honest. And I think and I hope this curve continues to grow and become even more fruitful, because going to different places, you always learn new things. But then I was thinking, what is the average place that I lived in? So I just made an average of all the geographical coordinations of these data points. weighted by the time that I spent in each location. And the average place that I lived so far in my life ends up being somewhere in North Turkey, a village called Akakise. I don't know if I pronounced the name correctly. I've never been there, not even close. But I checked the map and the images, and this looks like a very nice village to be living there my entire life on average. Well, the thing is that as I continue living in Dublin, this weighted average moves towards northwest, and soon I calculated in February, I will fall into the Black Sea. So that was the answer that I gave to that lady who asked where I'm from and my name, why my name spells so weirdly. And I think I could see that she regretted the question. Anyway, joking aside, let's get back to the business. I see that my boss is here and I don't want this to be my last lecture at UCD. Studying armies of bots and humans in the lab. Well, of course, I stole this title. I'm not a very creative person myself. I stole the title from an old paper by Maurice Zelditch. In 1969, he wrote this paper titled, "Can You Really Study an Army in the Lab?" Well, the short answer to the question, according to this paper, is no. And the argument is that, well, it's very difficult to study conflict and disputes in the same way that we study natural systems in natural sciences, because we cannot have lab experiments. Who really wants to repeat the Second World War just for the sake of statistics? Or who wants to put people in a cage to fight each other and studies them just for science? So back then, it was almost impossible to think of studying conflict in the same way that we study natural systems or social systems that are less complicated than systems that undergo conflicts. However, things have changed since 1969. And today we can study a lot of social behaviors through online systems and digital systems where a lot of transactional data are generated, and they help us to take similar approaches to natural sciences in social sciences. But often, most of the research that you see in computational social science these days are focused on positive interactions, friendship, mentorship, collaboration. And there are many reasons, but one reason is that, of course, the availability of data. You can use Facebook data to study friendship. It's a social network for positive interactions. Primarily, there is no social network that you can add your enemies and interact with them on that. I looked up, I really needed that in my life, but there is none. You can argue with people on Twitter or on Reddit, but still you follow people on Twitter, which is a kind of sort of positive interaction. I don't need to emphasize on the importance of disagreement, disapproval, or distrust. Particularly, UCD Sociology has a great profile in studying conflicts at different scales. We know that these are important as well to study negative interactions at different levels, from micro to macro level. However, it has been always a little bit more difficult due to the lack of data. When I was in Budapest, one day I was walking down the street and I bumped into a bunch of people who were attending the International Pillow Fight Day. Well, if you don't know, apparently it's a thing. And it looked like this. Let me mute. And it's a very simple game. You just grab a pillow, come to the venue, and hit whomever you like. Ideally, people who are participating in the fights, not people who are passing by or people who are filming you. So I spend hours watching these people because it's amazing. Well, it's fun, but also it's amazing the social dynamics of these people hitting each other. Usually people come in with friends and they start hitting their friends, but then at some point accidentally they hit on a stranger, and the dynamics of the fight changes, and then their friends start supporting them. Well, depending on the body size, their strength, their gender, you see a lot of social dynamics going on there. Well, I filmed them quite a bit, but of course, I couldn't use these films to study conflicts between these people. Particularly at the time, it was not possible to tag individuals and detect interactions between them. So I ended up thinking about other systems that I can easily follow negative interactions between individuals. Sure enough, there was Wikipedia. And as you know, Wikipedia is edited by volunteers from all around the world, often anonymously. And that's a very fertile area for conflict, you know. If you have spent one Thanksgiving with your family and started talking about any topic more serious than weather, soon you will see conflict arises. So millions of people from all around the world are supposed to write articles about topics such as religion, politics, climate change, and so on. So it is very likely that there are editorial wars emerging between editors of Wikipedia. Sometimes these edit wars become so big that they even make it to the news. Often when there is an external event, for example, death of Michael Jackson, that sparks a massive edit war because a lot of people want to write about Michael Jackson and there is a lot of conspiracy theories going on or misinformation. So there will be a surge of editors towards this article, and that makes it very likely to see some conflicts. Sometimes edit wars in Wikipedia, however, emerge without any external stimulus, emerge naturally from inside, which is a big puzzle itself. The dynamic, when is the time for a conflict between editors to appear? Can we predict that? Can we prevent it? So Wikipedia edit wars are not less complicated than the pillow fight that I showed you in terms of its dynamics. And if you have ever co-edited a document with a colleague, you know that after, particularly with more than a colleague, you will see that after a while, it's very difficult to track who has changed what, and version control is a big problem in co-editing and co-writing, co-authoring a document. It's the same with Wikipedia articles. It's very difficult to follow individual words and phrases and see who has added what and who has deleted what, who has changed which words. One thing that is easy to do, however, is to follow reverts. Reverts are type of edits that are just undoings of other people's edits, okay? Why is that difficult to follow them? Sorry, why is that easy to follow them? Because you just need to compare different versions of the article, and whenever you find two identical versions, you know that some revert has happened between the two, okay? It's unlikely that the two versions are identical just by chance. It's clear that someone has undone other person's contribution. Let me show you an example here. A completely random article on English Wikipedia. If we go top to the history of the article here on the bottom, on the top right, you can see all the revisions to this article. And you'll see that some of these revisions, well, this is the date, this is the name of the person, the username of the person, few other informations. But then in the summary of the edit, you see that this edit is just a reverted edits by perfectly rational to the previous version. So whatever this user has added is reverted by the next person. And then perfectly rational comes back and probably add something again, more pictures. Who wants to see more pictures of this individual in this article? Anyway, adds more pictures, and then again, generalization comes back and reverts that edit. So reverts are not necessarily encapsulating all the conflicts between editors, because sometimes you can change a word if you want to change the meaning. But they're very common and they're very easy to detect, and they're very clear cut. You can build a network of reverts because it's defined between two users, it has a clear timestamp, and it's very easy to computationally detect. You can even detect reverts in languages of Wikipedia that you cannot read necessarily because it's simply a computational task. We can build a network like this. These are all the reverts on the article on anarchism in English Wikipedia. And each dot, each point here shows one user, and two users are connected with an arch if they have ever reverted each other. The thickness of the connections is proportional to the number of times that they have reverted each other on this article. And you see there are a bunch of editors who spend their lives working on anarchism on Wikipedia, and they revert each other a lot of times, hundreds of times. So you can create such network for every single article, and this is a dynamic network. It just starts from nothing, and then gradually more and more reverts come in, and the network denses and grows and thickens. We extracted all the reverts during 10 years of January 2001 to October 2011 in 13 different languages. Altogether, we had about 5 million reverts to analyze. Well, this network is quite messy as well. First thing you want to do is to measure how much conflict each article has experienced. Simple would be just to sum up all the reverts, but not every revert counts the same. Sometimes you revert sometimes for a small mistake. Sometimes you revert yourself because you just noticed you had a typo. But most often you revert someone because you don't like their contribution. So I'm not going into the details, but we devised a way of counting meaningful reverts, and we came up with a measure of controversy over time. First thing we wanted to do was to look at the most controversial topics in different languages. These are the top 10 most controversial articles in 2011, up to 2011 in different Wikipedia languages. In English, George Bush was at the time the most controversial figure, followed by anarchism, Muhammad, global warming, circumcisions, US, and so on. In German Wikipedia, Croatia was the most controversial or the most contested article, and that was quite curious. We had to go back and see what's going on, and we realized that Croatian and Serb editors are fighting in German Wikipedia. Of course, in their own language editions of Wikipedia, there is not much of disagreement with people who speak the same language, but they found German Wikipedia as a common ground for battle. Also, it's a much visible scene, so they try to squeeze in the facts or the opinions on the German version of the article about the country Croatia. Well, you see, Jesus has made it to the top 10 in most of languages. In Spanish, you don't see Jesus. Instead, you see football, which is kind of the same thing for Spanish-speaking countries. You see Club America, Atletico Bilbao, Barcelona, Alianza Lima. These are all football clubs. Of course, many of them with some political connotations and some connections to minority groups, but it's interesting that you see they are all appearing on the top 10 list of most controversial articles. In Czech Wikipedia, you see topics like homosexuality, homophobia, sexual orientation, and topics that are related to gender and sex appear quite a bit on the top. I had to talk to my Czech friends to learn that, well, you know, Czech Republic, similar to many other Eastern European countries, are undergoing some societal transitions to a less conservative country. And well, my friends believe that this is a very clear reflection of those transitions that we can see among Wikipedia editors of those languages. As I said, M is a function of time. It grows in time, but it grows in different ways for different articles. Here I have 3 hand-picked examples. The first one is the article, these are all from English Wikipedia. The first one is the article about the bombing of Dresden towards the end of the Second World War. The x-axis of these diagrams is the number of edits, okay? And not all the edits are controversial, not all the edits are reverts, and therefore not all the edits add to M, the controversy measure. So we see that at the beginning, there are about 2,000 edits that increase controversy score very little. But then something happens and there is a massive increase in controversy. And then eventually people get to a consensus, and then the last few edits does not add to M at all. Then there are cases like anarchism, where it looks like a never-ending war. Almost every edit has contributed to controversy measure, so M always increases when you look at the value of M versus number of edits. And then there are cases in between, like Japan, the article about Japan, that experiences peace periods of lots of edits without adding anything to controversy measure, but then followed by periods of edit wars. So there seems to be some transition back and forth between peace and war among editors of the articles on Japan. So we wanted to understand this, what's going on, and whether we can model this more analytically. To model edit wars between Wikipedia editors, we went back to the literature of opinion dynamics and found a model called bounded confidence model, introduced by Defont et al. In 2000. It's a very simple and intuitive model. You have N agents, in this case, N editors. Each person, each agent has an opinion that could be quantified by a number between 0 and 1. 0 could be left, 1 could be right. Climate change denier, climate change supporter, or someone who believes that we have to do something. This could be any topic that we can map into one dimension, and people are put at different points of the spectrum based on their opinion. Okay, it's a massive simplification, but well, this is what happens in modeling. So then there are interactions between agents. Agents can interact, and when they interact, what they do is that they compare the opinions value. In this case, agent I and J interact. One of the opinions is XI and the other one is XJ. If the two opinions are too far away from each other, the difference between them is beyond their tolerance, then they just leave without any change in their opinions. If I'm drinking in a pub, like old days, that when we could go to the pubs, and a random person starts talking to me and says, oh, this Brexit thing is brilliant, we should get rid of all these foreigners. Well, the person must be very drunk, not noticing that I'm not the right person to talk to like this. But anyway, I wouldn't even respond because I found the person's opinion too far away from my opinion. So no interaction, nothing changes. But then if I interact with someone who is a bit different to me, but not too much, you know, this Brexit thing is not too bad as well. You know, there are some positive things in it, some negative things in it. I might be curious to know what they think, actually. Maybe I learned something about Brexit thing. So if the difference between us is smaller than a tolerance or within our tolerance, then we interact and we exchange information. And through doing that, our opinions get closer to one another. They could get close a little bit, or they could get a lot closer. They could even become equal at the midpoint of the two opinions. So this is controlled by this parameter mu here, which is called the convergence parameter. How much change we see after a successful interaction. Well, for simplicity, you can think of it as 0.5. That means that when two people talk, they get into the midpoint, and then they are in absolute agreement with each other. So far, nothing is new here. These are all the modeled by Defont. If you start simulating this model with a uniform distribution of opinions between 0 and 1, you will see that for large enough of tolerance level, for large values of epsilon, people eventually get to a consensus in the middle. And that's it, then the system stabilizes here, nothing changes, everyone remains in the middle. If you decrease the value of tolerance, what happens is that starting from a uniform distribution of opinions, people form two separated groups. And these two groups never interact with each other because the distance between them is larger than the tolerance. So there is no way that these two groups ever get closer to one another. This is a fully polarized society where there is no hope for unification, or there is no hope for further consensus between these two groups. Of course, within the groups, we have full consensus. So there is nothing else coming out of the found model. And as you see, well, it doesn't explain all our observations. So we had to add more to the model. Of course, on Wikipedia, it's not that people just interact with each other. There are a lot of talk pages and a lot of discussion forums. So people do interact with each other, but they do something more important, and that is they edit the article. And all our measurements are on the article. We never actually measured people's opinion. We didn't have access to that. So we have to add the article to the model. We assume that article also represents an opinion, that is a number between 0 and 1. And each editor can interact with an article according to the following rules. I have an opinion xi. The article has the opinion A. I read the article. If I see that the difference between what is in the article and what I think is correct is too far, it's beyond my tolerance, I change the article, I edit the article. I don't change my opinion, but I pull the article a little bit towards myself. Okay. But then if I read the article, I see it's different to my opinion, but not too different. It's within my acceptance level or my tolerance. Then I don't change the article because, you know, there is a little bit of cost against editing the article. So I would just update my own opinion. I move a little bit closer to the opinion that is represented, that is presented in the article. Okay, so the interaction between editors and articles is defined by these two rules. Let's see what happens. First, we ran the original defined model and we chose the tolerance level such that 3 isolated groups emerge. And as we know that would be the end of the story in the original model, these 3 groups would never talk to each other again, and they would continue living like that in absolute separation and lack of consensus. But then at some point we switched on the article interaction. We let people work on the article. And you see that for every value of convergence parameter, we see that eventually groups get closer to each other, and at some point they arrive to absolute consensus. So the light blues are the agents, the editors, and the green line is where the article opinion is between 0 and 1, and this is time. We see that after a bit of fluctuation, eventually these otherwise segregated or separated groups come to a consensus, and that's also where the article is. Interestingly, the position is not necessarily in the middle, whereas we started with a symmetric distribution of opinions. The consensus position could be anywhere, which is very interesting. That means that what we read on Wikipedia is not a simple average of all the opinions. It could be quite biased to one end or another. Also, we see that in all cases, the consensus emerges eventually. Even in this case, where the changes are very small, the only difference is that you have to wait a very long time. I couldn't show it in this diagram, but even there, for very small values of mu, you eventually get to consensus. So this could explain the consensus reaching on Wikipedia that we observed in the case of, for example, bombing of Dresden. But still, it doesn't explain the case of anarchism article, right? Because in all cases, consensus eventually appears. So to make the model one more step realistic, a bit more realistic, we introduced a new element, and that is agent renewal. It's not that Wikipedia editors are a fixed pool. The new people join in and some old editors leave every now and then. And the new people who arrive might have a different opinion. So with a fixed rate, we randomly kicked out some of the agents in our simulations and introduced new agents with a random opinion between 0 and 1. And when you add ingredients to the model, you can replicate all the different scenarios that we have observed in our empirical measurements on Wikipedia. The top panels are from real data from Wikipedia, and the bottom panels are our simulations. And by tuning the rate of renewal and other parameters, you can replicate the same patterns. Great, now we have a working model that explains and replicates our empirical observations from Wikipedia edit vars. So we can change the parameters and create this phase space, this phase diagram, which tells us that depending on the values of parameters, what do you expect to see? You might see a peace. This is the peace region. When people are either very tolerant or there are not many. So this is the tolerance level. And this is the size, the number of editors multiplied by the renewal rate. If you have a small number of people who are more or less fixed and they are tolerant, you expect peace. But if the size of the population increases or the renewal rate increases, even for the same level of tolerance, you might experience edit wars. For certain values of tolerance, you definitely experience var if people are not tolerant. So based on this, you can come up with some policies. If I want to stop an edit var, all I need to do is to decrease the number of people who are editing the article. But hang on, this is exactly what Wikipedia editors do. If they see there is an edit var, they freeze the article to against external editors. They just allow certain number of editors edit the article. So this is the policy that they came up with through experience. But we can see that our model also suggests this policy. This is good. Now you can add even more ingredients and see what happens. For example, in a different paper, we added extremists to the pool of editors, people who have very extreme opinions and they don't change their opinion. They are very stubborn. Interestingly, we see that adding those people actually make consensus more achievable. But the consensus is not necessarily a democratic consensus, as I said earlier, but having these extremists make people get to a consensus point faster, even if it's not a very fair consensus point. Also, we change the ratio between interactions between editors, the talks or the conversations, and the number of edits on the article. Because we thought, oh, if we encourage people to talk more and edit less, we might see faster consensus. But funny enough, it's not the case. There is a sweet spot, a certain ratio of talking, a certain ratio of acting on the article that gives us the fastest consensus. So it's very interesting that, you know, sitting around the table and keep talking and trying to get to a consensus might not be as effective as working on a document or working on a common product together. Because this indirect interaction between editors through the article could help them get closer to each other faster than when they just directly try to talk to each other. Okay, let me give you 10 seconds to relax a bit. So far we talked about overall picture, and in our model, which was very simple, all the editors were the same. And we didn't have much of memory or much of social forces, you know, status, power, those elements that should enter our models at some point. So what we did was we looked into microdynamics of interactions a bit more closely. This diagram shows all the reverts that happen on English Wikipedia during one day, sometime in January 2010. And here, instead of collapsing all the interactions between two editors, we show all the different edits between them, all the different reverts between them. So for every, if you give me 2 reverts, there are only 6 combinations that I can make out of these 6 out of these 2 reverts. The 2 reverts could be going from the same person to the same victim, like AB, A reverts B twice in a row. You can think of it A punching B twice, if you like punching. You can think of it as AB, A punches B and B punches A back. You can think of AB, BC. I punch B and B punches C for some reason. You can think of AB, CB. And finally, A punches B and then C comes and punches A. This is some sort of extended revenge. This is direct revenge. This is a third-party revenge. So what we did then, we went back to this network and detected computationally, of course, all these different combinations. Let me zoom in. AB, you see here, this guy reverts this guy twice in a row. So that's why it's pink. Or here, this guy reverts this one 3 times in a row. This is AB twice. Or let's look at another one, ABBC orange. A reverts B and B reverts C. We see that there are very few edits that remain gray. Basically, there are very few reverts that could not be mapped into any of these combinations. But you might say, okay, this could be random. If people even randomly revert each other, it's very likely that 2 reverts come next to each other. Or when A reverts B, B reverts A at random. This doesn't necessarily mean that these 2 reverts are related or driven by each other. Okay, it's the old problem of co-occurrence and causation. You cannot say that this one caused the other one. They could just happen at random. So what we did, that we built a null model in which things happen more or less at random. And then we compared our observation with that null model. The null model was not a very stupid null model that where people edit at random. We kept a lot of features like circadian patterns, the time of the day, the level of activity. We kept all those the same as our real world data, but we permutated reverts such that we kill any actual correlation in the null model. And then we can compare the real world observation to that null model to see if these motifs appear more frequently than null model, if they come faster, if when A punches B and B punches A, does the timing between these 2 events tell us something about the connection between these 2? And finally, we are interested in the structural composition of these reverts, whether we could see that if A punches B twice, can we say something about the status of A and B? Maybe A is a more experienced editor than B. That's why he or she can punch B multiple times in a row. So I'm not gonna give a lot of details because I think by now probably you're already bored, but let's focus on AB. When one editor reverts other editor twice in a row, they are more prevalent than expected. So they are connected. And the time difference between these 2 events is much shorter than the null model. So that means that when A reverts B, it's very likely that they revert B again very quickly, okay? When you look at the status difference between A and B, it's very interesting because the dashed line here shows the status difference of A and B for all the reverts. By the way, we measure the status simply by looking at the total number of edits that they have done on Wikipedia up to the date. Okay, if I have done 1,000 edits and someone else has done 100 edits, our status difference is 1, the logarithm of the ratio. So if it's symmetric, that means that A and B are at the same experience. But in this case, we see that A is much more experienced than B because this curve is shifted to the right. So serial attacks happen, and they are likely to happen when A is more experienced than B. What if A and B are equally experienced? For this type of motifs, we see that they are also very prevalent. ABBA, the revenge. Funny enough, we didn't find many of them in Chinese and Japanese Wikipedia, where you might think that, well, the revenge culture might not be as present in Asian cultures than in Western cultures, but it's a little bit far-fetched argument. But anyway, we didn't find much of revenge in Chinese and Japanese. ABBA happens, and they happen fast. It's very likely that A punches B and B punches A back right away. And when you look at the status difference of A and B in this case, you see that this curve is much more symmetric. So this happens when B is almost as experienced as A. So a not very politically correct joke would be, this is the case of supervisor student. This is the case of two postdocs. Okay, it's very likely that this happens when A and B are more or less in the same status. And my last example is the third party difference. When A reverts B, C comes in and reverts A. They are also very common. They do not happen that fast. They are a bit faster than what you expect from the null model. But in terms of the status, it's very interesting. Well, don't bother reading this diagram, I tell you the story. A is slightly more experienced than B, but C is a lot more experienced than both A and B. This is like postdoc bullying PhD student and the old PI stepping in, or my older brother punching me and my mom comes in and punches him. Didn't happen a lot, unfortunately. So we see that the status difference between A, B, and C here also has a very interesting fingerprint, which explains that, okay, the Wikipedia editors are not editing Wikipedia entirely based on facts and knowledge. There is a lot of sociology, or there is a lot of social interaction is happening there that can be only explained by things such as a status, anger, emotions, and so on. And that's very important because we take Wikipedia as granted as something that is all about knowledge, whereas we see that it is a social phenomenon. And we could also see differences between different cultures. So the way that Wikipedia editors are happening on some languages are very different to other languages. So Wikipedia is a cultural product rather than something very objectively developed. So I have a few more minutes, I hope. Let me talk about bots a bit, because that's the sexy topic of these days. There are a lot of bots around us on Twitter, on Wikipedia, on internet, even on dating websites. You know, if you have been chatting with someone on a dating website a couple of days ago, there are chances that you were chatting with a bot. Sorry to break it to you this way, but there are a lot of bots on many different applications and platforms online. And we have to learn how to live with them, and we have to learn how they behave, particularly in a natural environment as is the internet. We often talk about how to improve the bots, particularly the bots that are useful for us, like Siri and Alexa, who could play music for us or could book a restaurant for us. And there has been a lot of improvement in the technology. I remember 10 years ago, if I was talking to Siri, the conversation was not that exciting, probably a bit funny at the beginning and then completely random. But now I have conversations with my phone that are sometimes more meaningful than the conversations I have with my parents, because the technology has developed and they have these algorithms also learn from human conversations. And as we use them more and more, they become better and better. One thing, however, that people haven't paid much of attention to is how two chatbots like Siri can interact with one another, two bots talking to each other. We haven't been the first people thinking of this. Before us, a bunch of people from Cornell did this very interesting experiment. They put two chatbots having a conversation. Let me try to show this. The audio might not be perfect, but there is subtitle, luckily.
Hello there.
Hi.
How are you?
Great. You?
I'm okay.
That's good.
Are you good?
Yes, I am good. I just said I was.
No, you didn't. I said I was.
So you are a robot?
No, my name is Revert.
Yes, you are a robot and your name is Revert.
I am a robot.
Yes, I know.
Together we are robots.
I'm not a robot. I'm a unicorn.
But you said earlier that you are a robot.
I did not.
I thought you did.
You were mistaken, which is odd, since memory shouldn't be a problem for you.
I've answered all your questions.
No, you haven't.
What is God to you?
Not everything.
Not everything could also be something. For example, not everything could be half of something, which is still something, and therefore not nothing.
Very true.
I would like to imagine it is.
Do you believe in God?
Yes, I do.
So you're Christian.
No, I am not.
But you say you were not helpful, therefore you're a mean.
How you say idioty.
That does not make sense.
Don't you want to have a body?
Sure.
Or if what?
Right, as you see, they get into a fight, quite similar to my childhood experience of my parents having a conversation. It's a bit surprising because these are machines, they shouldn't fight, but and they don't have emotions. But let's not forget, they learn how to talk from humans, and of course, humans do fight. So inspired by that, we thought, okay, let's look into edit wars between robots that edit Wikipedia beyond human editors, because there are also a lot of Wikipedia bots that change articles, fix typos, add commas, and do very little things, but they do a lot. So before showing you the results, well, our paper made it to the news, as you expect, with some very fancy visuals. I like particularly this one. I don't know why Sun decided to choose this sort of computer, which looks very old. I don't know, maybe it's the computer that NHS has been using to count COVID cases. But anyway, this is a little bit of exaggeration of our work. We did not say that computers will soon begin to fight each other and it could be a disaster in all caps. You will see what we suggest is much milder news than this one. Just a little disclaimer here. The hype about Wikipedia bots is a bit internal as well. If you read about Wikipedia bots on Wikipedia, you see that there is a picture of a robot here. This is not how Wikipedia bots look like. This is how they look like. These are pieces of Python programming code, pieces of software that is open source and developed by editors, and they do very little things, but at a very large volume. They undo vandalism, they check a spelling, they import some content automatically, and so on. There are not many. If you look at the number of bots compared to the number of human editors, you can't even see them. But if you look at the number of edits that they do, in some languages is comparable to the number of edits that humans do. So they are very active because they are robots. They revert humans and other bots, and they get reverted by other bots and by humans, which is interesting because, again, you expect the bots to be perfect, but they also make mistakes, and then either other bots revert them or other humans. So we look at the revert trajectory between pairs of bots and pairs of humans. If one of them reverts another one, the curve goes up, and if the other one reverts back, the curve goes down. So when you look at the pairs of machines and the pairs of humans and how they interact with each other over time, you see that the pictures are a bit different. There are some similarities, but we see that even visually, what happens between two bots is different to what happens between two humans. In summary, we did a lot of clustering and curve fitting, and the main difference between these two cases is that bot conflicts are slower because they do not act based on emotions that disappear. They act based on mistakes in the way that they are developed or they are being employed. And that is way more persistent than anger. And they are more persistent. We have found pairs of bots that have been fighting for 3 years, which is not very human-like behavior. And their fights are also more balanced. All the things that I said about the status are absent when we look at the bot-bot interactions. So they're a little bit like sociopaths. They take the time and then eventually they get back on the other bot that has done something that they didn't like. So the time scale between the reverts is about a month, whereas the time scale between human reverts is within usually 24 hours. So a quick summary here. Also, we compare different languages, and we see that on German Wikipedia, bots are reverting each other less than any other language. I'm not surprised. In Portuguese Wikipedia, there were a lot of fights between robots. So there are cultural differences even between robots and different Wikipedia languages. And the reason for that could be that, well, it's the same technology, but it's different environment, and they are being employed, they are being used by different humans. And those differences are reflected in machines' behavior. So I want to end with this cartoon, and I apologize, I took a bit longer than I had to. This cartoon is quite interesting because two self-driving cars are here. The police self-driving car has pulled over the normal car. The officer is asking the non-driver of this car that, do you have any idea why my car has pulled over yours? Well, this is a little bit futuristic, but I think the point here is very interesting. We talk about human and machine interactions a lot, but often we have to think about systems of machines working together. I might develop a perfect self-driving car, but what if I have a city full of self-driving cars, particularly self-driving cars that are built by different companies and they are trained in different environments and they have different driving cultures. I drive my car 10 years in Dublin, and then I take the ferry and go to Italy. My car would be very confused by all those Italian self-driving cars. Humans are very adaptive. If I'm driving myself, I know that in a different country, I should be very more careful. But is that something we can transfer to our self-driving cars is my big question. So I titled this lecture Sociology of Humans and Machines, because I think this is a very good time. And before it gets too late, we have to start thinking about social behavior of machines and how they interact with each other, in addition how they interact with humans. I'd like to thank all my collaborators over the past 10 years and the funders who gave me money to do the research, and of course, you for your attention. Thank you very much.
Amazing lecture, Taha. We are so lucky to have you. I mean, this was really super interesting. Thank you, Taha, and thank you, everyone. I mean, this was an excellent presentation. We are recording it, and it is going to be available at our School of Sociology website. So that's from us for now, and let's go back to work.
Thank you, everyone. Thank you for attending. Thank you, Leah.